In this video, we're going to learn about slope fields. We've already talked about differential equations and coming up with a general solution, so something like dy dx equals 2x. When you solve it, you get y equals x squared plus c. So that plus c is what makes it a general solution, because you can have lots of different values for that. So if c equals 0, we get a parabola that looks like this. But if c equals, let's say 5, we get a parabola that's up here. Or if c equals -2, we get one that's down here. So we get a family of solutions, or a general solution. And if we graphed all of those solutions, this is what our graph would look like. So in here you can see there's if c equals 0, if c equals 1, if c equals 2, if c equals 0.1. But this is not a very useful graph, because there's an infinite number of solutions on here, which means basically we're just looking at a solid blue graph. So instead of graphing every part of all of those infinite number of solutions, what we do is we make a slope field. And a slope field, this is a slope field. So it's just a graph that shows the general solution for a differential equation, and we do that by plotting tangent lines at every point on this graph. So I can see sort of the shape of these right here. That looks like c equals 1. If I want to do c equals 0, it's sort of right here. But basically we're doing a connect the dots kind of thing, where we get the shape of the graph without having that solid blue mass where we can't tell anything that's going on, like on the last picture. Drawing the slope field is kind of tedious, but I'm going to show you how. So, an example, we're going to draw the slope field for dy dx equals 2xy on the given xy plane. So this was our given xy plane. And you'll see a picture of that without any slope fields on it in just a second. But what we have to do is for every point on the graph, so like point 0, 0, I've got my x is 0, my y is 0, and then I plug that into dy dx. So 2 times x times y is equal to 0, and then I draw a little line that has a slope of 0. And then I do that for the point 0, 1. So 2 times x times y still equals 0, so at the point 0, 1, at the point 0, 1, I have a slope of 0. And then I go through and I just do that with every point. So 1, 1 is 2 times x times y, which equals 2. So over here at the point 1, 1, I have a little tangent line that has a slope of 2. And to make it easier to graph, if it's something like a slope of 2 or -2 or something, I know that that means I'm going up 2 and over 1. So I'm kind of aiming at this point here when I'm leaving this one. So I'm trying, but I'm not connecting all the way up to that one. I'm just drawing a little line that sort of points towards this point. You don't have to be really super accurate with these. For instance, like this slope here is probably not exactly what it needs to be, but that's okay, as long as you get sort of the general shape of it. And then I can see that I would have something like this. If I trace out my function up here, if I have a function here, it's like a straight line. If I go here, this is probably going to be more like an upside down parabola. Anyway, so in general, what we're doing is we find the slope at every point, and then we draw tiny little tangent lines at each point using those slopes that we have found in this table right here. So here is yours to try. Draw the slope field for dy dx equals x plus y. This is what a blank plane looks like, so you only have to do the slopes at the points that they give you. If you're doing this on the iPad, you could pause the video and take a screenshot and then draw it right on this grid. Or if you want, you can also Google like slope field paper and find a bunch of paper that has blank slope fields on it. Anyway, pause the video, try the problem, and then when you restart, we'll look at what the slope field should look like. Alright, so here's what we've got. I didn't include the XY table because there's so many points, but basically you can see there are some patterns here too. So x plus y at 0, 0, it's 0. But when the points match up with each other, or when one of them's positive and one of them's negative, like here we have +1, -1, I'm also going to have a slope of 0, +2, -2. And that's true for this entire diagonal. So if I look at this diagonal, I see I've got slopes of 0 going all the way. And then same thing, each of these diagonals is going to have the same slope, so it makes it a lot easier to find the slope field. And then the same thing going this way, these all have a slope of 1, these all have a slope of 2. those have a slope of 3, 4, 5, and 6. Alright, now the other thing that we need to note is what we call particular solutions. So, in general, this is the same problem as the one that we very first started off, dy dx equals 2 of x. So I know y equals x squared plus c. But then you also have an initial condition here. So when x is 0, y is equal to 3. And that means that when I graph it, I get a parabola that has a y-intercept of 3. So y equals x squared plus 3, which looks like this. So now I only have this one particular solution. But before I could get to that particular solution, notice I had to find the general solution. So we kind of do the same thing with the slope field. So we have our general slope field in blue. That's y equals x squared plus c. And we saw that one before, but those are all the blue marks. And then we have our particular solution of y equals x squared plus 3. So the way to graph a particular solution is I start at the point they gave me. At x equals 0, y is equal to 3. So that's this point right here. And then I just follow the slope field. So I've got kind of a tangent line that has a slope of 0 right here. And then as I go over, I've got a slope of 1 and then a slope of 2. So it's going to get steeper. Basically, I'm just playing connect the dots, but with slopes. So first I'll draw this side, and then I'll go back to the point, and I'll kind of draw that side. And you can see it better maybe with a y-intercept of -2, because if I start down here, and then when I draw my slope field, I go this way, but then it gets steeper and steeper, so I go up farther and faster. Same thing on the other side. I'm just following what the slopes are doing. So basically, another way to think about this is like these are... The blue things are kind of like water, like current in a river, and so you kind of have to follow along with whatever the current is telling you to do, so we're just following that pattern. So here's an example. This one's a little bit weirder because it's got sort of this asymptote or discontinuity right here. So they gave us this function, y minus 1 over x squared, and it says to sketch out the general solution and then the particular solution that goes to the point 2, 0. So I did my general solution here in blue, and then in purple, when x is equal to 0, I get something that doesn't exist, so I just put like little x's there to show there's some sort of asymptote or discontinuity there. Something is happening. And then the point 2, 0 is right here. So I start with, my function has kind of a small slope, and then as it gets closer, as it gets higher up, then it has to flatten out some, but then it can't go past this. So I just kind of end it right there. And it's hard to see on this little tiny slope field, so I've got a bigger one right here. So we can see here's our point 2, 0, and then this one has a lot more slope lines on it, so it's easier to follow along with. So it started flat, and then it follows the slopes up, and then it flattens out again. But I have an asymptote or a discontinuity there. And then the other part of this function, you won't have to do one like this where you've got to find another part of it, so actually for right now, don't worry about that. Alright, so here's one for you to try. Here's a slope field. You don't have to graph it. It's already been graphed for you. And what I want you to do is sketch the particular solution that goes through the point 1, 1. So you have a choice. You can do that with your finger, like pause the video and then move your finger along the graph. Or if you're doing it on the iPad, take a screenshot and do that. Or you can try to reproduce this on a piece of paper. But I would highly recommend just using your finger on the video to do it. Alright, so pause the video here and then I'll show you what that looks like in just a second. Alright, so this is what our particular solutions should sort of look like. It doesn't have to be exactly the same thing, but here's my point 1, 1, because I went over 1 and up 1, so right here, point 1, 1, and then I just follow along with the blue lines, which gives me this sort of nice looking cubic function. And that is the end of this video. Ask if you have questions.